is Flash Isaac, and I'm a teacher from the future. In mathematics or in quantities, we can deal with quantities in 2 dimensions or 3 dimensions. 2 dimensions is referred to as 2D, and 3 dimensions is referred to as 3D. Look at something. If you are watching movie on your phone, or as you are watching this video, if I do like this, my finger is supposed to be pointing towards you, which is outside the screen. But it won't point outside the screen. The train will take it to side, or this side, or up. So it doesn't come outside. This is because your screen is 2 dimensions. 2 dimensions only has the y-axis or the s-axis. Then here is negative y-axis, here is negative s-axis. This is what we refer to as vertical direction. Vertical, this is horizontal. So this is negative vertical down, negative horizontal. 2 dimension, just s and y axis. Either this way, this way, this way, or that way. But dealing with 3 dimension, we have the third axis, which is the z axis, going like this. Take a look at your wall. Your wall is like this, s, y, and the z is pointing out towards you. If you watch all those 3D games, or you watch 3D movies, you use 3D glass, you notice that things basically fly out of the screen. They are coming towards you. Someone can just take a knife and do like this. You get so shocked because it's coming towards you. So that is the z-axis dimension. For this level, we are restricted to only 2 dimensions to resolve vectors in 2 dimensions. Since vectors are in 2 dimensions, or we are dealing with 2-dimensional vectors, and if something is going this way, like this, we will say vertical direction. So let's say an object going up 2 meters per second, we say, okay, we have a velocity of 2 meters per second in the vertical direction. If an object is going this way, let's say 4 meters per second, we will say that this object 4 meters per second going towards the horizontal. How about you have something like this, 2 meters per second. This guy is not in the vertical axis, it's not in the horizontal axis. So it's not in y, it's not in s. But we cannot leave it like this. We need to take it to either s or y axis. Not either. We'll take it to s axis, take it to y axis. Trying to take these vectors to their components, vertical and horizontal. That is resolution of vectors. Vectors that are not in the vertical or horizontal, trying to take them to those directions and trying to collect them. So getting vectors in their vertical direction or in their horizontal direction, that is what to do with resolution of vectors. Now, how do we resolve vectors? Or what should you know when it comes to resolution of vectors? For this is inclined. This is certainly an angle. If we say this angle is 30 degrees, for example, it means this vector is 2 meters per second at 30 degrees to the horizontal. 30 degrees to the horizontal. So angles are mostly formed with the horizontal or to the horizontal. And when you are given any vector, you must resolve it to the vertical direction. You also resolve it to the horizontal direction. So it is in both directions. This guy is in both directions. It is in horizontal, it is also in vertical. You first of all resolve it to vertical, then you resolve to horizontal. If vectors are moving in the same direction, they sum up. If they are moving in different directions, you subtract them. Look at this arrow. This shows this direction, and this. You notice that the 3 are moving in the same direction. If you push this one here, the arrow is facing here. If you push it here, the arrow is facing up, which is also in this direction. Anytime you are resolving vectors and you are wondering, when should I use cos and when should I use sine? When you are opening up the angle, you use sine. When you are closing the angle, you use cos. What is opening and what is closing? If I say resolve these 2 meters per second to the horizontal or to the x-axis, you are simply closing. You are resolving, you are pushing it down to the x-axis. You are closing this 30 degrees. So since you are closing, it is 2 cos 30 degrees. If I say resolve this to the vertical direction or to the y-axis, as you are pushing it this way, this angle is opening. You are opening it. Therefore, it is sine. Here is 2 sine 30 degrees. Which means, if I have something like this, and here is, let's say 60 degrees, here is 2 meters per second. If I am resolving this guy to the y-axis or to the vertical direction, I am closing the angle. I'm pushing it this way. The angle is closing. Since the angle is closing, it is 2 cos 60 degrees. If I am resolving it to the horizontal or to the x-axis, as I'm drawing this thing here, come down. You notice that the angle is opening. I'm drawing it, the angle is expanding. So here is 2 sine 60 degrees. So your mentality should not be that if you are resolving to the horizontal, it must be cos, and to the vertical, it must be sine. No. It depends on where you are, the angle, whether you are opening or you are closing the angle. Dealing with vectors, you will be asked to find the magnitude and direction. Magnitude of any vector is that particular number that gives us the effect of the two forces together. If I give you like this, here is 2 Newton upward. This is force. Here is, let's say, 4 newtons to this way. You need to look for one force that will give you the same effect as both of these forces acting together. That is the magnitude. That is the result. So the magnitude is usually this single force, or when you cross it like this your hypotenuse will represent the magnitude. From right angle to triangle, using triangles of vectors, we know that hypotenuse is equals the square root of opposite square plus adjacent square. Similarly, if you are resolving vector, the resultant of vectors is referred to arrow is equals the square root of the vertical vector squared. After you resolve to the vertical, your result square it plus the horizontal squared. The diagram above shows 2 vectors. 2 vectors, 6 going this way, 8 going this way. What is the value of the resultant vector? What is the value of the resultant vector? That is the single vector moving this way is the resultant vector. In this vector, you notice that we already have the vertical component. We already have the horizontal component. Both components are available. We therefore don't need to resolve anything to the vertical or to the horizontal since they are already given. It is only when they have not been resolved that we need to resolve. Since they already gave us, the resultant will simply be the magnitude of the vertical squared plus horizontal squared. This is the magnitude. Vertical squared plus horizontal squared, the square root of everything. And that will give you Vy is 6 squared plus Vs is 8 plus 8 squared. That will give you 10 newtons. 6 squared is 36 plus 8 squared is 64. 36 plus 64 is 100 and the square root of 100 is 10. So 10 newtons is the magnitude. So this is it. When you are given vectors in 2 dimensions, we resolve to the vertical axis and to the horizontal axis. To the y-axis and to the x-axis. Resultant is a single vector that gives us the same effect as the vertical and horizontal axis combined. And the magnitude of the resultant of any vector is the square root of square of vertical component plus the square of horizontal component. The direction of the vector is tan inverse of the vertical component over the horizontal component. Tan theta is opposite over adjacent, so capital. Opposite is basically vertical, adjacent is basically horizontal. You can use that to remember whether it is vertical that is at the top or horizontal that is at the bottom. Without wasting much time, let's take a look at standard questions under resolution of vectors. The first question here says, two forces, each of 10 Newton, act on a body. One towards the north and the other towards the east. If you have the cardinal point, this is your north, this is south, this is west, and this is east. The two bodies, one of them acts towards the north. So this one acts like this at 10 Newton. The other one acts towards the east at the same 10 Newton according to the question. This is east, 10 Newton. Looking at this, the magnitude and direction of the resultant force are, the magnitude will definitely be towards this aspect. It goes this way and it is in the northeast direction, northeast. The magnitude of the vector or the resultant of the magnitude will simply be, or the magnitude of the resultant is the square root of v squared plus h squared. In these forces, this one is already at the vertical, this one is already at the horizontal. No need to resolve since they are at that point. If they were inclined, we would have resolved to the vertical and to the horizontal. This isn't inclined, they are already in their respective axes. V is 10, so 10 squared plus horizontal h is also 10 plus 10 squared. This will simply give you 10 root 2. Root 2. That is the resultant, 10 root 2 Newton. The direction is tan inverse of v over h. So theta equals tan inverse of the vertical is 10 and the horizontal is 10. This is tan inverse of 1. 10 divided by 10 is 1, and this will give you 45 degrees. From the options, option A is wrong, option D is wrong. Now, B and C, in terms of magnitude of the resultant, are correct. How about the direction? Is the body moving towards the west? Obviously, there is no way body acting here and here will move in this direction or in this direction. It is not in that direction. The magnitude is obviously in this direction. So west will not even work. So east is the correct answer, 45 degrees east. Because the resultant is making an angle, is inclined to the horizontal. So 45 degrees to the horizontal east. That is the correct option, which is option C. A handbag containing some load weighing 160 Newton is carried by two students, each holding the handle of the bag next to him. If each handle is pulled 60 degrees to the vertical, find the force on each student's arm. Look at this. A handbag containing some load weighing 162 Newton. That is the weight. In physics, weight always acts downward. So this weight is 162 Newton. And so long the object is not going, is not falling, something is holding the object, it therefore means that there is a normal reaction upward, which is equal to the weight but opposite. So there is a force going up, that is 162 Newton. For an aeroplane to be moving straight up like this without falling, there is a force that is balancing the weight. So there is a lift force that is equal to the weight. Once lift is equal to the weight, a plane is able to balance. And when the thrust is more than the drag force, then the plane will move forward. Drag is force pulling it back, thrust is the force taking it up. So if it's able to push more thrust, it goes up. But once the drag is equal to the thrust, it will not move. The aeroplane will be staying in one place. If thrust is equal to drag and lift is equal to weight, the plane will be in one place. So for a body to be in equilibrium, the sum of all the forces acting is 0, because this one is equal to this, cancels. This one is equal to this, cancel. Since these students are holding the bag, it's not falling. So the total force acting up is the same thing as the weight of the bag. Now we are told that if each handle is pulled at 60 degrees to the vertical, so one student is holding this handle, or student 1 is pushing it, is holding this handle at 60 degrees. Student 2 is holding the second handle at 60 degrees. So this is the first tension, this is the second tension, because the force that is acting opposite to the weight or the normal reaction. From here, the force on each student's arm does not have anything to do with the horizontal, because weight is acting down, the force must try to balance the weight, and that force will be going up. We are concerned about vertical forces. From here, the force here or the tension here, they are the same, since they are both inclined at the same angle and they are trying to pull the same force. They are the same. Resolving this to the vertical, we have T cos 60 degrees. Resolving here to the vertical, we have T cos 60 degrees. We know that this is going down and this is going up. If that is so, T cos 60 degrees, in vectors, forces acting in different directions, they are subtracted. The ones acting in the same direction, they are added. So T cos 60 degrees plus the second T cos 60 degrees minus the weight is acting down, is equals 0. They cancel out. Therefore, T cos 60 degrees plus T cos 60 degrees, these two forces, they are equal to the weight, 162 Newton. We move it to the other side. All that being said and done, cos 60 degrees is 1 over 2. T 1 over 2 plus T 1 over 2 is equals 162. T times 1 over 2 is T over 2 plus T over 2 is equals 162. The LCM is 2. Then 2 divided by 2 is 1. 1 times T is T plus 2 divided by 2 is 1. 1 times T is T. So this is equals 162. T plus T, 2T. 2T over 2 is equals 162. So 2 cancels 2. The tension on it is 162. It therefore means that here is 162 cos 60, here is 162 cos 60. So 162 is the force on each student's arm. Now let me show you one magic in physics. You will tell yourself, if this is 162, here is supposed to be half, here is supposed to be half. But look at something. Anytime you are dealing with inclined objects, you need to be very, very careful. Fine, if you say 162 plus 162, adding both of the forces acting on the student's arm, you get 324, right? But look at it. If T here is 162 and T here is 162, let's resolve this T to the vertical. You have 162 cos 60 degrees. Cos 60 degrees is what? Half. So this is 162 over 2, and that is 81. You see? So this 162 is inclined. Once it is inclined, the real value will go back to 81. But 81 is not your answer. Because if you say T is 81, once you resolve 81, you get half of 81. In summary, the tension is 162. The first on each student's arm. So 162 here, 162 here. If you resolve 162 to this place, you get 81. You resolve this 162 to this place, you get 81. When you add both of them, it is equals to the weight. So upward will now be equal downward force. That is physics for you. Very interesting and sweet. If the angle between two vectors P and Q is 0 degrees, the vectors are said to be dashed. If angles between two vectors is 90 degrees, the vectors are said to be perpendicular. A situation where the angles between the two vectors is 0 degrees, it means one is like this, one is like this. When you have parallel lines, the angles between them is 0 degrees. So if the angle between two vectors P and Q is 0 degrees, the vectors are said to be parallel. Option A is the correct option. Look at this typical question. This is what I've been waiting for. The figure above shows 4 forces: 3 newtons, 10 newtons, 3√3 newtons, and 6 newtons acting on a particle P. The resultant of the 4 forces is dash. I love this question. This is question after my heart. Let me draw the diagram. Force 1, another force, and another force. And we are asked to look for the magnitude or the resultant of the 4 forces. No matter how many forces we have, whether we have 50 forces, 70 forces, or 30 velocity, 70 velocity, no matter the number of forces or vectors, we are resolving. Forces are vectors, velocity are vectors, acceleration are vectors. So if you are resolving forces, you can say resolution of forces or resolution of vectors. Acceleration, the same thing. So all the vector quantities we listed, you can resolve them. And they can be resolved into the vertical and horizontal axis, since we are dealing with 2 dimensions. The first thing we look for is, let's find all the vertical components. Vertical components can be vertically up or vertically downward. For vertical downward, that is negative, because if up is like this and down is like this, up and down are opposite. You subtract down from the up. For the horizontal, this is positive S, this is negative S. Positive Y, negative Y. So the ones acting this way are opposite to the ones acting that way. So I shall simplify it. For the vertical, we have 3√3. No need to resolve because it's already in this vertical. Now, this guy and this guy, since they are inclined, it means they are in 2 axes. They are both in vertical and in the horizontal axis. Any inclined body can be resolved or is resolved into both the vertical and horizontal. Our concern now is the vertical. Let's resolve this guy to vertical. Resolving 10 newtons to the vertical, it is, look at the arrow is going here. So it is the same direction with this, plus 10 sine 30 degrees. You notice we are opening up this angle. It's inclined to the horizontal. We're opening it up. So we sine plus this guy, this 6 newton, we can resolve it to the vertical. Resolving this to the vertical, we are opening up this angle. So it is sine. But look at the arrow. When you resolve it here, the arrow is going down. It's opposite these ones. Since they are in different direction, we have to subtract. So here will be plus, okay, plus normally, but for here it's minus 6 sine 60 degrees. Any other component? No. Let's see the horizontal. For the horizontal, we have here Not inclined. So you write only it. No need to add angle or cos or sine. Not inclined. So 3 plus. Let's resolve this now to the horizontal. 10. Resolve it to the horizontal. We are closing this angle. So that is cos 30 degrees. Then this can also be resolved to the horizontal by closing 60 degrees. Since this direction is opposite this direction, here will be negative. So we say plus minus 6 cos 60 degrees. So this is 3 root 3 plus 10. Sin 30 is 1 over 2. 1 over 2. Plus times minus is minus. So we have 6 times sin 60 is root 3 over 2. Root 3 over 2. This will give you equals 5 Newton. For the horizontal, we have 3 plus 10. Cos 30 is root 3 over 2. Plus times minus is minus. 6 times cos 60 is 1 over 2. So this is 1 over 2. This should be equals 8.7 Newton. We are asked for the resultant. The resultant will simply be equals vertical squared 5 squared plus horizontal squared 8.7 squared. That should give you 10 Newton. What if we were asked for the direction? Direction theta is equals tan inverse of vertical 5 Newton over horizontal 8.7 Newton. So this will give you the direction. Ladies and gentlemen, I hope resolution of vectors makes sense to you. Now, let's see another question. The diagram above shows forces 4 Newton, 6 Newtons, 10 Newtons, and 8 Newton, which act at a point O in the direction indicated. The net horizontal force is dash. This question is concerned only about the horizontal force, not the vertical force. So the horizontal force will simply be the ones acting in the same direction are 10 Newton plus 8 cos 60 Newton, cos 60 degrees, plus 6 cos 60 degrees, because 6 cos 60 degrees is acting in the same direction as 10 Newton. 8 cos 60 degrees is acting in the same direction as 10 Newtons. But the 4 Newtons is acting in opposite direction. It therefore means everything here minus 4 Newton, which is acting in the opposite direction. Cos 60 is that 1 over 2? Yes. So 10 plus 8, 1 over 2, plus 6, 1 over 2, minus 4. Horizontal is equals 10 plus 4 plus 3 minus 4. 14 plus 10 plus 4, 14. That is 13. So this is 13 Newton. So that is the answer to that question. And this question is requiring us to find the net vertical force. The last one says net horizontal force. This one says net vertical force. The net vertical force is the ones acting in the same direction are 25 Newton. Then we see 20 Newton. The 20 Newton, resolving 20 Newton to the vertical, that will give you plus 20 sine 60 degrees. Because the 20 Newton is acting towards the horizontal. To resolve it to the vertical, it is sine. We are opening the angle. Opening of the angle is sine. So plus 30 cos 45. The 30 Newton is acting towards the vertical. The one that is going opposite is the 20 Newton. So everything here minus 20 newtons. That will give us the net vertical force in the diagram, as we can see. If we are looking for the net horizontal force, it will be 30 sine 45 degrees minus 20 cos 60 degrees. And the resultant will obviously be vertical force squared plus horizontal force squared. The direction will be tan inverse of vertical over horizontal. So resolution of vectors is something very, very easy. So I don't know why you've been scared to resolve vectors. Thanks for watching. Your one and only teacher from the future. I hope you found this class interesting. Feel free to check out the playlist for more amazing videos. And don't fail to install the Flash Learners application right now for notes, videos, and questions to meet all your needs. Subscribe to this channel so you don't miss out any of my sweet videos. See you in the next episode. Don't forget to tell everyone around about the Flash Learners. Bye.